until you understand, right? But very easy, concept oriented. The continuity concept is concept oriented. It's not like matrices determinant. That is the general concept, algebra. Okay, let us go for the differentiability. This already, whatever the formula, yeah, this formula clear. It is a first principle of calculus. This is first principle of calculus. Right, first we'll discuss the concept here. All of you observe. Actually, dy by dx, dy by dx is derived from, dy by dx is derived from this formula. If you see in depth, limit delta x tends to 0, delta y by delta x is given by this dy by dx. This is can be written as limit delta x tends to 0, f of x plus delta x minus f of x by delta x. Actually, this is also derived from delta y. Delta y, the rate of change of y. See, I am going to explain you very clearly the in-depth concept of this. See here, generally, the explicit function can be taken by y is equal to f of x. So y is equal to f of x be the given function. Y is equal to f of x be the given function, right? So here delta y is can be written as see, this is a given function. I'm going to take x-axis, y-axis. This is x-axis, this is y-axis. All of you observe here. I'm taking the curve. Okay, this is the given curve y is equal to f of x. And on the curve, I'm taking any 2 points. Like this is P, this is Q. I'm taking P comma Q. The point P, I'm taking as x comma y. P is x comma y, Q is x plus delta x comma y plus delta y. Okay. So here, what is the mean by this? X plus delta x, delta x, delta y. So this delta x is the change of x variable. Delta y is change of y variable. Okay. So here the point is this the x and y, right? When I draw that like this is x, this is y value, this is x value. When I extend here, yeah, this is x plus delta x. Up here x here, this is delta x totally. Sorry, here this is y, this is delta y. This is x, this is delta x. When we join in these 3 points, we are going to get a right angle triangle. Am I right? Right angle triangle. So here dy by dx nothing but m, that you know very well. In geometry you studied m nothing but slope. Slope is given by dy by dx. Very important. This is also can be written as tan theta. This is also can be written as y2 minus y1 by x2 minus x1. Okay, but here we are discussing the differentiability. Dy by dx, the rate of change of y with respect to x. Generally, it is given by like this. So this is a slope at the tangent. Slope of the tangent, dy by dx, always slope of the tangent. So when I join these 2 points, when I joining like the 2 points, what are the 2 points? P and Q. Look at it. This P and Q. What about this secant? We are going to get a secant. Is the secant is a tangent to the given curve? For example, circle. Is this a tangent or secant? The line? Yes, secant. So dy by dx means it is exists for only tangent. So to get the tangent, what shall we do here? So q approach to p. Q approach, when q is approaching to p, when for example q becomes here, when q tends to here, I'm taking q here, q becomes here. What about secant? The secant becomes like this. When q is approached here, the secant becomes like this. When like that, so on, like when p becomes, actually q tends to p here. Q is approaching to p. When I q is coincide with p, nothing but when q is equal to p, then the secant becomes a tangent. Okay, there is only one point. At one point, we are going to get a tangent. Tangent. Nothing but what? Delta x tends to 0. When delta x value tends to 0, delta y value becomes 0. So x plus 0, y plus 0, then the q becomes p. Then we get tangent. Tangent having slope. Slope is dy by dx. Okay. So see here, y is equal to f of x. Y is equal to f of x. Right? Then delta y is equal to f of x plus delta x, and y is equal to f of x, delta y is equal to f of x plus delta x. So what I want to do is, I want to find sorry, here y plus delta y is f of x plus delta x. Remember student, y plus delta y becomes x plus delta x. Okay, like that. Y is equal to f of x, y plus delta y becomes x plus delta. So here I required only delta y. Delta y can be written as x plus delta x minus y. So what is the y actual again? Y nothing but f of x. So delta y is equal to f of x plus y minus, sorry, x plus delta x minus f of x. Okay, I want to divide it with on both sides with delta x whole divided by delta x. So after that, I want to take limit on both sides. Limit delta x tends to 0, delta y by delta x. Nothing but the point q is approaching to p. You may get doubt, sir, why can't we take delta y tends to 0? No, here y is a function in terms of x. Y is depending on x. When x is changing, y also automatically changing, right? So this is a limit delta x tends to 0, f of x plus delta x minus f of x by delta x. See here, so now this is the actual dy by dx. In first principle of calculus, we simply written f dash of x. Okay, f dash of x is equal to this value, we written dy by dx. dy by dx is equal to, we written like. So here, for the sake of our convenience, I want to take this delta x as h. Now h tends to 0, f of x plus h minus f of x by h. This is the first principle of calculus that already you studied in class 11. Okay, that already you studied in class 11. So the rate of change of y with respect to x is given by dy by dx. Okay, so a few applications will be there, that is natural growth and natural decay, bending of beam, electrical circuits, many orthogonal trajectories. Okay, like body temperature. So all are depending on the applications of derivative. Few applications which is belongs to the first order dy by dx means first order derivative. This is d power 1. We differentiating only once. If I write d square y by dx square, this is second derivative. So first order derivatives application 3 will be there, that you will be studying in your future. Like in higher studies, we are going to study natural growth, natural decay, like body temperature, temperature of the body, like And higher studies is that is only simple harmonic motion, bending beams, laws, Kirchhoff laws, LR circuits, LCR, like circuits. Those properties actually depending on the derivative, right? Okay, fine. This is the first principle law of calculus, not required to this derivative part. Just I have explained how we got the first principle derivative, right? Okay, fine. Now, so here I want to say something here. There are again like continuity also we are having two formulas. In the same way, here also we are having two formulas. Here also we are having two formulas. One is formula one in continuity, direct formula. What is the continuity second formula? LHC, left hand continuity should be equal to right hand continuity. That will be equal to f of e. Here also same. This is one formula, and the second one is same. Left hand continuity and right hand continuity. So I'm going to write the formula here. Y is equal to f of x. The given function is differentiable at x is equal to c or x is equal to a. Okay, at x is equal to c. If limit x tends to c, f of x minus f of c by x minus c is existent. This limit must be existent. Then this limit value is taken by f dash of x. Okay, f dash of x, or at x is equal to c, or also this also can be written as f dash of c. This is the derivative of f of x, right? Or this is also can be written as dy by dx at x is equal to c. In another way, the same formula we'll write like this. Okay, this is in terms of h. This is in terms of x. Okay, what is the left hand derivative, right hand derivative? Left hand derivative means limit x tends to c minus f of x minus f of c by x minus c. Or this is also can be written as in terms of h. H tends to 0 minus. Here always h tends to 0, not h tends to c. 0 minus f of c plus h minus f of c by h. So c minus means left hand derivative. Then right hand derivative same. Either we can write limit x tends to c plus f of x minus f of c by x minus c, or we can written as limit x tends to h tends to 0 plus f of c plus h minus f of c by h. So try to remember the second formula alone. H tends to 0. You are not required, no need to remember the first one. So try to remember this second. Left hand derivative, right hand derivative. So here also, when LHD, left hand derivative, is equal to right hand derivative, then only we can say that the function is differentiable at a given point. If it is not equal, the function is not at all differentiable. Okay, and the next point, if you want to say, if I want to say like the function y is equal to f of x is differentiable, differentiable in closed interval a comma b. So what is the mean by this? This is a, this is b. I want to take closed interval. There is a graph like this. I want to check from a to b in closed interval a comma b. I want to check this curve y is equal to f of x, whether it is differentiable or not. So what is the mean by this? What is the mean by this? So it is nothing but f of x is differentiable in each and every point, in the interval open interval a comma b, and at x is equal to a and x is equal to b. Why? Because of the reason is closed interval means the end points a comma b also belongs to that interval. So it should be the meaning of this closed interval means it is differentiable at each and every point in given interval. Like each and every point, nothing but if you take any point in between, like this point C, C is lies between from A to B. At C, the left hand derivative must be equal to right hand derivative. That is the meaning. If you find the left hand derivative at C, right hand derivative at C, both must be equal. Both must be equal, both must be coincide. Then only it is differentiable. Like the meaning when we say the function is differentiable in closed interval, it is differentiable at end point as well as each and every point between A and B. So in the same way, open interval also. Open interval means not necessary that it is differentiable at end points and other than that end point. Okay, that is the meaning, right? So methods are there. This is the complete concept of differentiability at a point. Differentiability at a point. Right, students? And also remember here a few important note. Okay. For example, note 1. First note. F of x is differentiable, which implies f of x always continuous. Next, second point. Second point is that f of x is continuous, which implies f of x may not differentiable. You can take any differentiable function, So it is always continuous. Like I want to take f of x is equal to like cos x. Cos x is differentiable. Cos x is always continuous. But the function is continuous. It may not be differentiable. For example, I want to take modulus x. The modulus x is a function which is continuous but not differentiable. Modulus x is not differentiable. That we'll see that modulus x y it is not differentiable because left hand derivative should not equal to right hand derivative. That is the reason the modulus x is not differentiable. Right? Sometimes f of x is, for example, not continuous. I'm saying that not continuous, which implies f of x always not differentiable. When the function is not continuous, it is not differentiable always. Example, already we've seen one example. What is the example we have seen? Anyone? I want to take step x. Greatest integer function is not continuous. In the same way, greatest integer is not differentiable always. And the fourth point is f of x is not differentiable. Not differentiable, which implies f of x may be continuous. May continuous. We can take many examples. Simple example. Already we taken that example. See here, modulus x. Modulus x is not differentiable at x is equal to 0, but it is continuous. Modulus x is continuous at x is equal to 0. The function which is not differentiable, also it is continuous. But the function which is not continuous means always not differentiable. Okay. And also remember the property. For example, f comma g are any two different functions. Both will be differentiable. F is differentiable, g is differentiable. Then f plus g is also differentiable. F minus g also differentiable. F into g also differentiable. F by g also differentiable. G not equal to 0. And also remember that whenever you want to find the left hand derivative, right hand derivative, nothing but what we need to find the limit value. Limit extends to c plus c minus h tends to 0. So limit value always should be finite, like continuity. limit of the continuity function is what? Always finite. If you get infinite, that is not continuous. Not continuous means not differentiable. So limit always should be finite. If you want to discuss about either continuity or differentiability, the limit value must be continuous. Okay, here what I given, f comma g are differentiable, then these are the differentiable. Okay. Next, second point I want to take. The time is over. You can stop last point. F comma g are not differentiable. I'm taking not differentiable. I'm taking which is not differentiable. Then what about f plus g? Is it differentiable or not differentiable? It may be differentiable. May be differentiable. Can you give any example? Yes, we can give example. I'm taking f of x is modulus x. G of x is minus modulus x. What about their sum? F plus g. F plus g value is 0. 0 is a constant. It is 0, always differentiable, always continuous, everything. So f of x is not continuous, g of x is not continuous because modulus function always, sorry, not differentiable. Not differentiable even though their sum is differentiable. In the same way, product, here f is not differentiable, g is. What is f into g is equal to minus x square. So minus x square always differentiable. So f comma g are not differentiable even though sometimes f plus g, f into g, not always. But we can't say that f plus g, f into g always not differentiable. So it may be differentiable also. So my suggestion is for you all students, once you go through that, whatever I send that video which is belongs to differentiation module 1, go through that because clearly I explain all the methods. The same methods we will discuss next class. Next class onward, those methods we are going to discuss because all are becomes very easy for you instead of wasting time.